This is section 1-8, perimeter, circumference, and area. These are all formulas that you should already be familiar with that you've seen last year or the year before. So this will just be a nice quick review. The perimeter of anything. The perimeter is the sum of the lengths of the sides of a polygon. So sum meaning add. Perimeter is the distance around a figure. So all you're going to do is add up all the sides, whether it has 3 sides, 4 sides, or 8 sides. So perimeter is the sum of the lengths of the sides of a polygon. A polygon, remember, is just a closed figure made up of line segments. So a triangle is a polygon, a square is a polygon, a parallelogram is a polygon. A circle is not a polygon because it's not made up of line segments. So perimeter is the sum of the lengths of the sides of a polygon. Area is the number of square units a polygon encloses. Okay, so area is going to have different formulas depending upon the figure. So you would use perimeter for something like if you were putting up a fence around your property, or if you were putting up border around in a room, around the walls. It's the distance around something. Area would be if you were putting tiling a floor, you're putting carpet in a floor. Okay, so that would be area. So let's start with a square. So a square has all sides that are congruent, and we're going to study squares and rectangles and parallelograms later on. But you can see these little slash marks are showing that all sides are the same. We're using S for sides, and it has all right angles. So if I wanted to find the perimeter, which is the distance around it, I'm just going to add up all the sides. So I can either add up all the sides, or since all the sides are the same, I'm just going to multiply 4 times one of the sides. So P is a perimeter. And A is area. Area is just base times height, or in this case, since the sides are all the same, you can just use sides squared. Okay? A rectangle. Now a rectangle has opposite sides congruent, so these two sides are congruent, so that's why I have the 2 slash marks, and these two left and right are congruent, that's why I have the 1 slash mark. So again, if you want to find perimeter, you can just add the base plus the height plus the base plus the height, or you can shorten that up a bit. You could do 2 bases plus 2 heights, or add the base and the height and multiply it by 2. And then the area is inside, so the area is just base times height. And that's a rectangle. Now a triangle, this triangle has sides of A, B, and C. So again, to find the perimeter, I would just add A plus B plus C. And that formula for area of a triangle is half base times height. Some of you might have learned it as base times height divided by 2, but that would be the same thing. And the height is always this line right here. It's drawn from the top and it's perpendicular to the base right here. So the height does not necessarily have to be one of the sides. It can be only if it was a right triangle. It's nice and easy to remember because basically a triangle is, if you take this rectangle and you draw a line down the diagonal, a triangle is just half of a rectangle, so that's why the formula is half base times height. The last figure that we have here is a circle. Now a circle is not a polygon. A circle has a diameter, and the diameter has endpoints on the circle, and it goes through the center, and the radius goes through the center, and it has one endpoint, so it's half of the radius is half of the diameter. So in a circle we don't talk about the perimeter, but we do talk about the circumference. C stands for circumference, and circumference is either pi times diameter, or circumference is 2 pi r. And the area of a circle, A is for area, is pi r squared. Okay, so that's our circle formulas. Let's try a problem together. Let's try and find the perimeter of this triangle that's in the coordinate plane. Now the perimeter is the distance around, so it's the sum of all the sides. Now GF would be easy to find the distance. We can just actually count from G to F the boxes, or we can take the absolute value of the difference in the coordinates here, the x coordinates. And FE would be easy to find. Again, it's just a horizontal. If it's a horizontal or vertical line, it's very easy to count these boxes. So I just start here and count 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we're going to find GF and EF. So FG is 3 minus negative 3. I'm actually just doing the absolute value of those x coordinates as 6, but again, I can just count the boxes. Start here, 1, 2, 3, 4, 5, 6, and I already counted EF, and that was 8. Now GE is a different story. I can't count the boxes because it's not a vertical or horizontal line, so I have to use my distance formula, and that's that square root of x minus x squared plus y minus y squared. So if you want to pause the video and try and do that on your own, and then I'll have the answers here. Okay, so it's x minus x squared, negative 3 minus 3 squared, plus negative 2 minus 6 squared, y minus y squared. And that's all under the radical. So 3 minus negative 3 squared plus 6 minus negative 2 squared. I actually did it the other way around, but either way you do it, you get the exact same answer. So you just got to work out those. Negative 3 minus negative 3 is going to be 6 squared, and 6 minus negative 2 is 8 squared. And that's 36 plus 64, which is square root of 100, and which of course equals just 10. And the question I have for you, is there another way that I could have found EG instead of using the distance formula? So see if you can come up with a way that I could have found EG without using the distance formula, and come in ready to share that tomorrow.